Welcome to Data and AI with Varath. On this channel, we break down complex topics into clear, practical explanations. Before any data engineer builds pipelines, before any analyst creates dashboards, and before any AI model is trained, someone has to design the data foundation. That responsibility belongs to the data architect. When architecture is done right, systems scale smoothly. When it is ignored, problems appear months later, often when it is already expensive to fix. As organizations grow, data grows even faster. Data comes from applications, cloud platforms, APIs, external partners, and operational systems. Initially, teams move fast and build what is needed, but over time, data becomes inconsistent, duplicated, and difficult to trust. The data architect role exists to bring structure, long-term vision, and stability to this growing complexity. Data architects operate above individual tools or projects. Their decisions affect multiple teams and future systems. They focus on standards, patterns, and principles that keep data platforms consistent and scalable as the organization evolves. A data architect does not start by creating tables. They start by understanding the business. Before a single column is defined, they ask fundamental questions. Who is the customer? What exactly is a product? What does a transaction represent in this business? What events actually matter? These business concepts are then translated into data entities. Customers become customer entities. Products become product entities. Orders, invoices, payments, and interactions become transactional entities. This step is critical because these entities form the backbone of the entire data model. In real projects, especially in SQL Server environments, this is where many systems fail. Teams rush directly into tables, columns, and indexes, but without a clear entity definition. The same customer may appear in 5 different tables with different names, different identifiers, and different meanings. A strong data architect ensures that every table has a clear business meaning. Every relationship reflects how the business actually operates, and every schema maps back to a real-world process. When this foundation is done correctly, data remains consistent as systems scale. When it is done poorly, performance issues, data quality problems, and endless reconciliation work appear months later. This is why data architecture begins with business concepts, not databases, not tools, and not technology. A wrong data type choice often looks harmless at the beginning. Everything works fine during development. Even the first few months in production feel stable. But 6 months later, when tables grow into millions of rows, indexes become larger and harder to maintain. Queries that once ran quickly start slowing down. At that point, teams stop building features and start firefighting performance issues. A data architect anticipates this future and designs for scale from day one. Operational systems are the backbone of day-to-day business activity. Every order placed, every payment processed, every inventory update, and every user action flows through these systems continuously. These systems are often called OLTP systems, online transaction processing systems. Their primary goal is simple but critical: record business transactions accurately, quickly, and reliably. A data architect designs OLTP schemas with this responsibility in mind. Data must be correct at all times. Transactions must either fully succeed or fully fail. Partial updates are unacceptable. In real-world systems, especially during peak business hours, thousands of users may be interacting with the system at the same time. Orders are being placed, payments are being confirmed, and inventory levels are being adjusted in real time. This is why OLTP schemas are highly normalized. Each table has a clear purpose. Relationships are carefully defined. Constraints, keys, and indexes are used to protect data integrity. A wrong design decision here can be extremely costly. Poor indexing slows down transactions. Incorrect relationships cause data inconsistencies, and badly designed tables create locking and blocking issues under load. A strong data architect ensures that OLTP systems remain fast, reliable, and accurate, even when the business is operating at full scale. Analytics systems exist to answer business questions. How are sales trending this quarter? Which products are performing well? Where are costs increasing, and why? These questions require scanning large volumes of historical data. They involve aggregations, joins across multiple tables, and comparisons across months or even years. Transactional systems, however, are not designed for this type of workload. They are built to record individual transactions quickly and safely. Mixing heavy analytical queries with live transactions creates serious risk. In real systems, running analytics directly on OLTP databases can slow down order processing, delay payments, and even cause outages during peak business hours. This is why data architects deliberately separate OLTP and OLAP systems. OLTP systems focus on accuracy and speed for day-to-day operations. OLAP systems are optimized for reporting, analytics, and decision-making. This separation is not an afterthought or a performance tweak. It is a fundamental architectural decision that protects the business while enabling meaningful insights at scale. Security, compliance, and governance are not optional layers added later. They are part of the architecture itself. Security answers a basic question: who is allowed to see or change this data? In real systems, not everyone should see everything. A customer service agent may need access to customer names. A finance user may need access to revenue numbers, but only a very small group should ever see sensitive fields like personal identifiers, salaries, or payment information. A data architect designs security directly into the data model. This includes role-based access, row-level security, column masking, and environment separation. Compliance answers a different question. What rules must the organization legally follow? Regulations like GDPR, HIPAA, or SOX define how data must be stored, who can access it, how long it can be retained, and how it must be audited. Compliance is enforced through architecture and security controls. For example, if a regulation requires customer data to be accessible only to authorized roles, the architect enforces this through access controls, auditing, and encryption. Governance focuses on trust and consistency. Governance defines what a metric means, who owns it, and which version is considered correct. Without governance, two dashboards can show different revenue numbers, even though they use the same data. When that happens, meetings stop being about decisions and start becoming arguments about whose numbers are right. A data architect prevents this by defining data ownership, standard definitions, naming conventions, and certified data sources. Good architecture ensures that data is secure, compliant, and trusted before problems reach leadership. Data architects rarely work alone. In fact, most of their impact comes from how well they work with others. They collaborate closely with data engineers who build pipelines, analysts who consume data, security teams who protect sensitive information, and business leaders who define priorities and success metrics. A data architect acts as a bridge between business goals and technical execution. They constantly explain trade-offs. Why one design improves performance but increases costs. Why another design simplifies analytics but requires changes in upstream systems. They also manage expectations. Not every request can be delivered immediately. Not every shortcut is safe in the long term. One of the most important responsibilities of a data architect is ensuring that today's decisions do not block tomorrow's growth. A quick fix that works for 10 users may fail when the system supports 10,000. A design that solves one team's problem may create issues for others. Strong data architects think beyond individual projects. They align teams around shared standards, guide discussions with facts and experience, and make architectural decisions that support both current needs and future scale. Data architecture defines how an organization uses data. Strong architecture enables reliable analytics, scalable platforms, and successful AI initiatives. Weak architecture leads to performance issues, inconsistent reporting, and costly rework. In the next video, we will explore how data engineers take this architecture and turn it into real data pipelines. Thank you for watching. If you found this video helpful, please like, share, and subscribe. More data and AI explainers are coming soon.